Hello, my name is Quentin Odenthal, and this video is about the use of parametric equations in projectile motion modeling. I will first talk about the nature of projectile motion. I will then describe parametric equations' use in modeling the projectile motion. Then finally, I will explain my interest in parametric equations, as well as some interesting properties of parametric equations, because there's some fun graphs you can make. Part 1. The nature of projectile motion. All things are affected by gravity and thus act a certain way when thrown. Things fall down. On Earth, gravity accelerates all things towards its center, at about 9.8 meters per second squared, depending on where you're at. But gravity isn't the only force acting on things. For example, air resistance, wind, and the spinning of the turbines on planes all affect planes in flight. All these added variables make the motion of flying objects somewhat complicated, and that's where parametric equations come in, because they take the function that would model a projectile's motion that's all kind of wacky, and then it splits it into two or more parametric equations that take into account each dimension, up or down, left, right, forward, backwards, and put them in terms of t, time. And this opens up many possibilities to gain information about an object's movement. So instead of seeing like where it goes, you can tell how far it's, or like at what rate it's accelerating to the left specifically at a certain time. And that's why parametric equations are used in physics to model projectile motion, because it's very, very useful. Part 2. Parametric equation use in modeling projectile motion. As a thing moves through the air, it's both falling down and moving forward, and in some cases left and right. These two directions are split into functions of their own respective axis, so forward and backward would be like x, then left, right, maybe y, up and down z, stuff like that. And then they're put into terms of time, t time, so you can tell where you're at height-wise or whatever at time t. And these functions are known as parametric equations. Many things can be done with these equations, one of which is to find the acceleration or velocity in any direction, any time, like I said earlier, and then it splits it into two or more parametric equations that take into account each dimension, up or down, left, right, forward, backwards, and put them in terms of t, time. And this opens up many possibilities to gain information about an object's movement. So instead of seeing like where it goes, you can tell how far it's, or like at what rate it's accelerating to the left specifically at a certain time. And that's why parametric equations are used in physics to model projectile motion, because it's very, very useful. Earlier, all you need to do is take the derivative of whatever parametric function you have. So if you have the function for how it was moving left to right, you could take the derivative of that, and then you'd have the velocity at whatever time moving left or right, specifically, which is very useful. All you need to do is take the derivative, and then boom, you have it. And if you want the acceleration, you just take the derivative again. Really handy. Another use of these equations is finding the location of a projectile at a certain time, not just the velocity. Because if you had an equation like y equals negative x squared plus 10, which is like an arc for something thrown at whatever, I guess -1 gravity, which, whatever. And you wanted to know where it was at time 2 seconds, it's kind of hard to figure that out. But if you have it split into the x and y components in terms of time, you just put the t in there. It depends how you split up your equation into what two parametric equations. You would have to know what your y value or your y acceleration was specifically. But you could split them into two parametric equations and then put your time in there for both, and then you could find where it was on the x plane, and then the y plane, you have the exact point it would be at 2 seconds, which is pretty cool. Parametric equations are also used to depict orbits, as they are just things in constant freefall. So orbits are just items, objects that are constantly in freefall. They're just going fast enough that they never actually hit the ground. And since they're just things in freefall, you can use parametric equations to model their motion. Earth's orbit, for example, can be expressed by the following equation on screen. And that's really complicated, and I'm not actually sure how to use it, but you can use it to determine where the Earth is at any time, t. And that's pretty cool. Part 3. my personal interest in parametric equations and some fun graphs. I personally find parametric equations super interesting because they take a complex movement graph that's like as the thing moves or whatever, and they split it into simpler pieces for each plane that they're moving on. And those are actually really useful. And I don't know, I just find that interesting. And also, they make really fun graphs, like this one, and this one, and this one. Those are all super cool. And no other functions make graphs that I think are that cool. I don't know, I really like those. Conclusion. Parametric equations are surprisingly good at modeling the weird movement and forces we experience in this universe. I still find it super interesting how I don't know, but they're really good at modeling motion. I think that's super cool. And for that reason, I find them extremely interesting and entertaining. And now I'm sure you're sick of hearing me say parametric equations, and I'm sick of saying it, so thanks for watching and have a nice day. I hope you enjoyed.